Hello, grade nines. So we were so close to finishing off our conversions from fractions to decimals, but we just had one strategy left. Before we talk about the strategy, I want to talk to you just as a quick recap of what we've learned so far. So the first thing we talked about, the surefire way to always and forever convert fractions into decimals is long division. Now, long division this year should be a last resort. It is long, it is tiresome, it is not at all the most efficient way to get there, but if we're ever in a jam, we don't remember a certain strategy, or we want to double check our work, then we can always resort back to long division. The next thing we talked about was our 6 sight fractions, the fractions that we should immediately know the value for the decimal of without even doing any sort of single computation. Okay? These 6 fractions are kind of like building block fractions because if I know these 6, I can find a lot more, right? If I know 1/4, I can use that to find 3/4. If I know 1/10, I can use that to find 6/10, etc. So those 6 fractions should be locked and loaded in our brains. Next, we talked about fractions with a denominator that's a power of 10. So that means their denominator is 10, 100, 1,000, 10,000, 100,000, a million, etc. Now, these fractions can be converted based on place value. So if it had a direct power of 10 as a denominator, I can use the place value to write the last digit of the numerator in the place value indicated by the denominator, and then backfill all the other digits in the numerator until I get to that decimal place. Now, we also discussed what happens when I have fractions that don't technically have a power of 10 as a denominator, but I could make into an equivalent fraction that has a power of 10 denominator. So this strategy of powers of 10 denominators using place value to convert to decimals work even if I don't have a denominator that's already there. But if I have a denominator that could easily be converted into an equivalent fraction with a power of 10 denominator, that can also be something I use. The next strategy was denominators made up of the number 9s. So the number of 9s in the denominator told me how many digits would be written underneath the repeating bar. The numerator told me which digits I write under the repeating bar of my decimal. But remember, the strategy only worked for proper fractions. So if I ever had improper fractions, fractions whose value is greater than 1, I had to turn into a mixed fraction first and then use my strategy, using the whole number as the value prior to the decimal place and the proper fraction to convert the decimal that comes, or the decimal value after that decimal place, that repeating portion. Now, the last strategy that we're talking about is going to be when I have a denominator that ends in a 0. Now, this does have some overlap with some of our other options, right? Because our second strategy was about having powers of 10 in the denominator. And you might be like, Ms. T, all of those powers of 10 denominators end in a 0. Why is this any different? But if I have a denominator that ends in zeros that isn't a power of 10, there might be another way to convert. And I want to talk about that strategy. So, if I were to briefly ignore those zeros in my denominator, and only if the zeros are at the end of that denominator. So if it's like 306 as the denominator, that's not what I'm talking about. But if the denominator is 300, notice the zeros are at the end of that number. That's the kind of fractions I'm speaking about. So if I ignored those zeros at the end of my denominator, and I thought to myself, hey, that fraction without the zeros in it in the denominator looks really familiar. I could, in theory, convert that fraction without the zeros into a decimal. That is the time where I could use a strategy that I have here. And what that strategy is to convert that fraction, ignoring the zeros, into a decimal using whatever strategy I would have used originally, whether it have been one of my 6 sight fractions, whether it would have been something with 9s in the denominator, or any of the others. And then what I'll do to my final answer is I will shift the decimal depending on the number of zeros in the denominator that I had originally ignored. Now that might sound quite confusing, so let's kind of break it down a little bit. Here's an example that we have about 1/2. Now 1/2 is one of those sight fractions where I look at 1/2 and without even thinking, I immediately know the value is 0.5. Now that's great. I'm pretty happy about it. Life is good. But look at 1/20. Now 1/20 isn't something I might know off the top of my head. Maybe you do, and if you do, awesome. But maybe you don't. Now 1/20 and 1/2 are very similar, except that extra zero exists in the denominator, and it's a trailing zero, which means the zero comes at the end of the number. Now notice the answers or the conversion values of the decimals. For 1/2, it's 0.5. For 1/20, it's 0.05. The difference between these two numbers is I would have had 0.5 and I shifted the decimal 1 to the left one time because there is one extra zero in that denominator as opposed to 1/2. If I notice in the next fraction 1/200, that's 2 zeros that trail in the denominator. And if I look at the decimal conversion, 0.5 is what 1/2 is, but this answer has the decimal moved 2 places over because I have 2 trailing zeros in the denominator. If I looked at the fraction 1/2 with 5 zeros in the denominator, or 1/200,000, well, I have 1, 2, 3, 4, 5 zeros. I know that normally I would have 0.5 for 1/2, but that can't be the answer. I need to move that decimal place over 5 times. I think I wrote this too close. Try this again. I have to move that decimal place over 5 times. So 1, 2, 3, 4, 5 to be able to get that decimal conversion done properly. Come back. So I can use those trailing zeros in my denominator to help me figure out what that final decimal conversion is going to be quite quickly. And that works for any of the different strategies I've learned, not just sight fractions that we have. So we have a couple examples here, and the first example is 1/30. Now, when I think about this, here's my thought bubble. I think, wow, that looks a lot like 1/3. And I know 1/3 is a sight fraction. I know that's 0.3 repeating. Now, based on the fact that there's 1 0 trailing in my denominator that makes 1/3 different from 1/30, that must mean my conversion for my decimal is going to have 1 extra 0 in front of the number coming after the decimal. Everything gets shifted over 1 decimal place. So instead of having 0.3 repeating, I have 0.03 repeating. And notice that that 0 isn't part of the repeating piece because it's simply a shift in the decimal place. So if the 3's were the only thing repeating before, the 3's are still the only thing repeating now. For the next one, -2/900. Here are my thought bubbles. This really looks a lot like 2/9. And yes, I realize it's negative, but the negative doesn't change my conversion at all. So I'm simply just going to slap a negative onto my final answer because the negative in no way changes my strategy. Now, 2/9, we know that 9's in the denominator indicate a repeating decimal. The numerator tells me what is repeating. There is only one 9 in the denominator, so I only have one digit repeating, and that's how I got 0.2 repeating. Now, 2/900 has 2 extra zeros in that denominator, which means I'm going to shift the decimal place over 2 additional times. So instead of the answer being 0.2 repeating, I'm going to have 0.00 and then the 2 repeating. Now, you might be yelling at the computer, and I might say, guys, don't yell at the computer here. I know, I'm missing a decimal. Nope, not a decimal, a negative. Whew. I have not included the negative yet, but here it is. Ta-da! If it was a negative fraction, it's going to be a negative decimal. No big deal. Okay? We cool? We good? Okay. Now, there are 8 examples here, all varying from what the different strategies are. I want you to pause the video. I think a lot of you have already tried these examples. So pause the video. Once you're done the examples, let the sub know to play the video. And then make sure you got your 8 examples done well. Cool? Okay. Hopefully you unpause the video now. Okay, I'm going through, and the first thing I see is 1/5. 1/5 is one of my sight fractions, and I'm like, boom, 0.2. The next one, to the right, I have -4/5. Now, that negative doesn't freak me out, so I'm just going to immediately slap a negative on my final answer. Now, if I know that 1/5 is 0.2, then 4/5 is like 4 times 0.2. And 4 times 0.2 is 0.8. That's how I got it. Another way you could have done this, some people might have said, if I have -4/5, I can make this into an equivalent fraction where the denominator is a power of 10. So you might have got -8/10, which gives me -8/10, which is what I have in decimal land over here. Okay, 2/3. -2/3, actually. So I have that negative. I know 1/3 is 0.3 repeating. That is one of my repeating decimals, but also is one of my sight fractions. So -2/3 is going to be double that. Double 0.3 repeating is going to be 0.6 repeating. Another way you could have tackled that is by equivalent fractions and said, hey, I'm going to times the top and bottom by 3 to get -6/9. And then have gone back in the same way to decimal land to get -0.6 repeating. The next one I might be like, whoa, I don't know anything about 33s in the denominator, but good thing I can make equivalent fractions. No need to brag. But that gives me 30/99. Hopefully you look at 33 and go, I can't turn that into a power of 10. So you rule that out. And you think, oh, I could turn 3s into 9s. And that's how I knew to go in that direction. And when I do that, I know 2 9s in the denominator means I have 2 digits repeating. Those 2 digits are the value in the numerator. So I get 0.30 repeating. The next one I have 1/25. Now, I might not know things about 25, but I could again make equivalent fractions because I don't have 25 as the denominator of my sight fractions. I could turn it into a power of 10, and that is exactly the strategy I would go for. So I'm multiplying the top and bottom by 4 because that gives me 4 out of 100. And when I convert that into a decimal, that's 4/100ths. So I'm going to put 4 in the hundredths place. The next one, I've got 0.8, and that's a sight fraction. That's 0.125. Woo! The next one, G, I get -1/40. Now again, I know that's negative off the bat, so I'm just going to slap a negative on there. And 40 isn't one of those denominators I know and love, but if I were to briefly ignore the 0 in the denominator, kind of looks like 1/4. And I know 1/4, it's one of my sight fractions. It's 0.25. But I know that having an extra 0 in the denominator will shift the decimal place over 1. Ah! Oops. Well, hopefully that didn't make you dizzy. Which means I'm going to have an extra 0 after that decimal place. Since there's 1 0 after that 4 in the denominator, there's one extra 0 before my decimal when I convert it. So instead of 0.25, I get 0.025. And again, if it was negative to begin with, it's negative to end with. Last but not least, I have -7/90. Again, if it's negative to begin with, it's going to be negative to end with. Again, 90 isn't one of those denominators that I'm feeling like I love. But if I ignored the 0, I'd be like, ooh, I like 9s. 9s are nice. And 7/9 would give me a repeating decimal. 1/9 means one digit repeats, so I would have 0.7 repeating. But since it's 7/90, one extra 0 implies that I need to include one extra 0 before the value after my decimal. So I get 0.07, and then that 7 is repeating. Okay. There is some practice that follows. What? Oh my gosh, there it is. Please complete that practice. You have the rest of class to work on it. Yay, you got this. I believe in you. Okay? Otherwise, if you could please get that done for Monday, that would be fantastic. I hope you have a great rest of your day. Bye for now.